Hi all, this is Lakshmi, working as assistant professor in the Department of ECE at SNS CT. So today I'm here to discuss about the lecture series on IoT system design, and the topic which I'm going to discuss here is about the smart agriculture. So before moving into the topic, first let us apply the design thinking concept here. So here the empathy part for the smart agriculture is, so we have to first analyze what farmers think. So how can they reduce the water wastage? So whether the technology would improve the crop or the automation will reduce the manual work or is it affordable? So these are the factors where the farmers would think. So they are concerned about the climate changes, worried about water scarcity. They're interested in modern farming methods and also they are hopeful for increased productivity. So what they say is, so they need efficient irrigation methods. Monitoring the crops manually is difficult, so smart farming could save the time. Technology should be simple to use. So, what actually the farmers are doing now is they monitor crops regularly, water fields manually, and they check soil conditions frequently, explore modern farming technologies. So, here the pain which they are facing are water shortages, the labor intensive farming, crop diseases, unpredictable weather conditions, etc. So, here when the smart agriculture is taken into the consideration, so they could gain the automated irrigation, better crop management, reduced labor cost, increased crop productivity, and efficient resource utilization. So this is the empathy part here. So smart agriculture, what it actually does is, so it can optimize the farming practices, improve crop yields, and reduce resource wastages. So smart agriculture using Raspberry Pi provides an innovative and affordable solution for modern farming. So by combining the sensors, automation, and Python programming, the farmers can achieve efficient irrigation, resource conservation, and improve agriculture productivity. So, the building blocks of the smart agriculture here is, so so this is mainly the application of the modern technologies such as sensors, IoT, automation, and data analytics in farming in order to improve the productivity, reduce the manual labor, and conserve resources. So here, using Raspberry Pi, the farmers can monitor the environmental conditions and automate agricultural process efficiently. So first thing is that they have to monitor the soil moisture, temperature, and humidity. Second step is they have to automate the irrigation system. They have to reduce the water wastage, improve the productivity. So first here, the hardware components required are the sensors in order to collect the data, soil moisture sensor, temperature and humidity sensor, the relay module, Raspberry Pi module, water pump, jumper wires, breadboard, and the power supply. So the software requirements are Raspberry Pi OS, Python programming language, Thorny IDE, and GPIO libraries, and the power supply, activators, and the communication modules. So as far as the hardware components are concerned, so we make use of the sensors which we have discussed, temperature, soil, moisture, humidity, etc. The communication protocols, power supply, and the controller here is Raspberry Pi. So the working principle here, the programming architecture is the first step is data collection. So sensors will collect the soil moisture level, temperature, humidity, and then is the data processing. So processor sends data using Python program, processes the data, and the automation is done here. The Raspberry Pi activates the relay. The relay switches on the water and the irrigation stops automatically. So when the moisture reaches the required level, the pump turn on. So this is the workflow. First is data acquisition, data processing, activation, transmission, and User interaction. So sensors will monitor the environmental condition. Microcontroller will analyze the data and activates the activators here and the motors, and the process data is sent to cloud. Farmers can access the data and control the system. So various setups are given here as a flowchart. So communication model, controllers, sensors, and activators. So the future work here could be integration of these IoT and embedded system with the AI ML. Various machine learning and artificial integrations can be done in order to improve its efficiency and other features. So this is the overall mind map of today's smart agriculture. So initially we have discussed the empathy part, its requirements. Then we have discussed about the hardware components and the software, the key libraries of the Python integrated development environment and the workflow of data acquisition, processing, etc. So today's assessment, what is the main purpose of using Raspberry Pi in smart agriculture? It is mainly for automating and monitoring farming activities. Which sensor is commonly used in smart agriculture to measure the soil condition is soil moisture sensor. Thank you.